Proof practice review number 2. This one has more of a focus on angle proofs, but I think there's at least a couple segments in here too. So your test is going to have a few of both. Alright, so we start every one of these with a given, just like before. This one says angle 1 and angle 2 are a linear pair. You don't even really need to be told that. It's right here, you can see it in the picture. We're also told angle 2 can be replaced with angle 3. Alright, so let's go with number 2 then. So if you go to your theorem list, again it's an angle proof, so that eliminates a lot of our theorems right away, because many of them deal with segments only. But so I see linear pair in the given, so I look on the paper to find linear pair theorem. It's right here, the only one that says anything about a linear pair. And all it tells me is if they're a linear pair, which they are, then I can write angle 1 and angle 2 are supplementary. So that means that for number 2, the next thing I can write is angle 1 and angle 2 are supplementary. And that's from the linear pair theorem. Alright, so then I got to work with what I have now. So I have angle 1 and angle 2 are supplementary. Well, I know what that means. That means that angle 1 plus angle 2 equals 180 degrees. And that's because what supplementary means. When you say the meaning, it's the definition of it. Definition of supplementary angles. Okay, number 4, well, I've used this and I have yet to use 2 and 3, so I'll take out the 2 and put in a 3. We've been doing that a lot. That's substitution. So we're utilizing our given. Now that's gone. So I'm basically what I want, right? I want angle 1 and angle 3 are supplementary. I've now shown that, so all I can say then is angle 1 and angle 3 are supplementary. That is the definition of supplementary angles. Okay, we move on to number 2. We have a picture, but we also have a given that gives us something pretty specific. So I usually suggest that before you do anything with the picture itself, you go to the given and see what you know from that. When it says AB is an angle bisector, okay, now I'm looking at this picture, and I mean there are ways I could go with this. Like I could have started with the idea that angle 1's measurement and angle 2's measurement, if I add them, I would get this whole angle. But because I have this bisector thing, it means I know something more than just that. It actually means I know that angle 1 and angle 2 are equal to each other. So AB is an angle bisector. That's going to help us out. I'm going to write this as a given, sorry. There's my whole given. So this is our start though right here. So again, if you look at the theorem list, this is on here, and it actually uses the same exact letters. If AB is an angle bisector, we know it is, then angle 1 equals angle 2. That means I can write angle 1 equals angle 2. So in this diagram, it's actually the exact same picture. So angle 1 and angle 2 are equal. That's my start to this proof. And that comes from the definition of an angle, because these are angles, an angle bisector. So I go to number 3. Okay, so I use that part of the given. So I got to use this. Take out 1 and put in 3. So I'll take out this 1 and put in a 3. That's substitution. So I need 2 is congruent to 3, so mine's actually backwards, so I guess I should flip it around. Angle 2 equals angle 3, that's symmetric. That's from the algebra proof lesson. And then because it wanted a congruent symbol, I'll use a congruent symbol instead. And to change equals to congruent or vice versa is just the definition of congruence. So that one actually has 5 steps. You could probably shorten it to 4. Like for example here again, right? If I recognize that I need 2 on the left and 3 on the right, when I wrote this first line, maybe I could have written it as angle 2 equals angle 1. It means the same thing. And then when I did the substitution, it would have been on the correct side to begin with, and I would not have needed this symmetric step. So it's possible that you could do this one in 4 rather than 5. But the way I happen to write it, I just chose to end up needing 5. Okay, so we have kind of a classic segment addition one. This one you saw sort of something very similar to it on the other one. So our given, this isn't going to fit on this paper like this. The given is AB equals CD, and to prove AC is congruent to BD. Okay, so we know, so we can see it here. This is the given line, this is the proved line. So there's not much in the given except for one substitution thing. So that's not good enough to start this. I don't have any midpoint, I don't have any bisector, so I got to go with what I know for sure, which is segment addition postulate. So without any bisector or any midpoint stuff, this is basically my last resort, but at least it always works. Okay, so in the end I want to prove AC is congruent to BD, so I got to give it a proof. So here's AC, right? Just like that other one we did on proof practice 1. AC is a combination of AB plus BC. So I would write AB plus BC equals AC. And the other one is from B to D, that's BC and CD. That equals BD. So that's what our segment addition postulate gives us. So right away I say to myself, well, I better use my given. AB is the same as CD, so take out the AB and replace it with CD. Otherwise, leave everything the same. So I took out that AB and replaced it with CD according to my given. All that is a substitution. So we're at that point again in the proof. Again, we're starting to see a pattern to these, that I've used all the givens and I've used whatever picture I have. So I'm not done, so I need to figure out how to get this to be done. So I would look at this and say, well, here's the AC and here's the BD that I want. If you can recognize that this and this, even though they're written backwards, they are the same thing. So CD plus BC or BC plus CD, that's the same idea. So what we have is AC, which is equal to something, and BD, which is equal to the same thing. Since they're equal to the same things, they're equal to each other. So we can write that, and that's transitive. Transforming two equations into one. And since it was supposed to be congruent, looks like we have one last, what you might call nuisance step. Change it to congruence. Definition of congruence. That's almost identical to one of the ones in proof practice number 1. Okay, here's the next one. Again, these two are the given lines. This is the proved line. I'm just going to write the given, abbreviate a little bit. Okay, number 2. So where's our start? In this case, the start, I think, should come from the given because we have something pretty specific. Angle 1 and angle 3 are complementary. That gives us a lot of information. So that tells you right away that angle 1 plus angle 3 must equal 90 degrees. That's us using our given. Okay, so that means this is the definition of complementary angles. Keep using the given. Substitute the 2 and the 3. So I took the... Oh, okay. I should make a note here. This says angle 2 can be substituted for angle 3. Well, in our proof, if you stop like right here, there is no angle 2 in it, but there is an angle 3, and we want angle 2 to end up in it. So I don't want to substitute it out, I want to keep it in. So this actually works in reverse, right? So you want to use it the way that makes the most sense, right? So you can take out a 2 and put in a 3, but again, in our line there, we didn't have that. And in our proof, we want angle 2 to be in it, so why would I substitute it out? I want to use that the opposite way and say I can take out a 3 and put in a 2. You just want to make sure you only do it one way in your proof. So in this case, I'm going to choose to take out 3 and put in 2. That's what I did here. So it works the same way. It's still substitution. You just want to make sure that when you're substituting, when you're substituting, it makes sense for what you're doing. Angle 1 and angle 2 are complementary. That's where we're at, so I can write it in words. And this one is done with the definition of complementary angles. Alright, I think the last one on here was a big one. It was a bonus question from a test a while ago. So this is no joke. This is a somewhat challenging one. So let's see what we can do with it. So we've got a good bit of given stuff. We got a picture, and in the end we need to prove angle 3 equals 50 degrees. Okay, here we go. So let's try to approach it the same way as all the others. So we'll list what we know. In the given. There we go. So, alright, we have angle 1, angle 2, and then the whole thing called angle ABC, and I also have angle 3. So that's kind of a lot of stuff to work with in this thing. We'll have to get them in the proof somehow. But we got a lot of given stuff that we can use. So I look at this and say that's going to be a substitution kind of thing. I'll be able to take out angle 1 and put in 90. I'll also be able to take out an ABC and put in 130, but the thing is I don't have angle 1 or angle ABC in this proof yet. And I also have angle 2 and angle 3 are complementary. That's something I can use too. So why don't we do this? Why don't we say, okay, since I'm going to be substituting out an angle 1 for a 90, and I'm going to eventually be substituting out an ABC for 130, why don't I try to get angle 1 and angle ABC in this proof somehow? Let's use that as the start. Well, what do I see over here? I see 1 and 2, and I see that those two together add to make angle ABC. So that's the way I'm going to start this one. Angle 1 plus angle 2 equals angle ABC. And that one is angle addition postulate. So that's one of those, when in doubt, if there's nothing else you can do, start with that. But that did get us angle 1 and angle ABC, things that we're going to be needing to substitute. we have them in the proof now, which is good news. So let's start using some of this stuff. Okay, angle 1 is 90, so I can take out the angle 1 and put a 90 in it. Angle 2 is going to stay, but angle ABC is 130. So that uses this and this. And that's substitution. Okay, but like if you look at this, I could actually solve what angle 2 is equal to. Right? Because I mean, I think I already know 90 plus whatever angle 2 is equals 130. We know it's going to be 40 degrees. But I can't just write that. I have to show how I do it. So this is plus 90. I'm going to take this 90 away. So I'm going to write the whole thing over again. But I'm going to show that I'm subtracting 90 from both sides. This is subtraction. So then number 5 would be that after I clean that up, I get angle 2 equals 40 degrees. And since that was just a cleanup step, that's substitution. So here's the thing, okay, so I managed to prove that angle 2 equals 40 degrees. The problem is I was supposed to prove that angle 3 is 50 degrees. But if you look at where I'm at, I'm kind of like, it looks like I'm done. So where do I go from here? Well, remember that we did not use all of the given yet. We still have this idea. So what does that tell me? Well, if I go to line 6, I know that angle 2 plus angle 3 equals 90 degrees. And that's the definition of complementary. So I've now used that. But see, look at these two ideas right here. Well, I can say that angle 2 is 40. Well, if that's the case, I can take angle 2 out and put 40 in its place. So I'll put a 40 here. That's substitution. And now I want to get rid of that 40. So I'll rewrite it. But I'm going to show that I'm subtracting 40. That's subtraction. And when I'm done, step number 9, I see that that's equal to 50 degrees. And that's substitution. And that one's done. That's a great geometry proof, because what that does is it makes you use the givens, you use a starting point that isn't written in the given. There's a whole lot of stuff in that one. That is a good proof. Alright, if you finish that one, I mean, I'd say you'd have a pretty solid handle on geometry proofs, angle and segment. So, give yourself an autograph. Excellent job.